Okay, so we want to know, we're dealing with ACT questions, and we want to understand, we're randomly guessing 5 of those questions. ACT questions are multiple choice. They have 5 answers each. So if you're randomly guessing, then the probability that you get an individual question right based on a random guess is 20%. It's just 1 in 5, right? And the problem tells us that we're taking 5 random guesses here, okay? And we want to know if X is the number of correct guesses we make. This is a random variable. We want to know what's the probability that X is greater than 2. That's what we're asked to find here. Okay, this is a pretty simple standard binomial problem. This is a binomial distribution. This is a binomially distributed random variable, since we're dealing with independently identically distributed Bernoulli random variables. Same probability for each. We're taking multiple trials. We want to know what percentage of, or what number, the binomial distribution describes the number of successes that we get if we run that process. So the first thing we need to notice here is we're asked for the probability that X is greater than 2. Well, that's actually just the same thing as 1 minus the probability that X is less than or equal to 2. Okay? And for a binomial distribution, a binomial can have valid values of X, 0 up to n. We can have no successes, or we can have n successes, or we can have any integer in between. So if we want the probability that X is less than or equal to 2, well, that's just the same thing as the probability that X is equal to 0 plus the probability that X is equal to 1 plus the probability that X is equal to 2. Like this, okay? How do we calculate these individual probabilities here? In other words, for a binomial distribution, in general, what is the probability that X is equal to some particular value of X? Pardon my chicken scratch here. This is a capital X. This is a lowercase x here. So we're asking, what's the probability that the random variable denoted capital X is equal to a particular value, lowercase x, right? Well, the general formula for the binomial distribution, if you have n trials and the probability of P, is n choose X times P to the X times 1 minus P to the n minus X. Okay? So if we use this formula for the binomial distribution, we can plug that into our expression over here and get at least a numerical form for what this is going to be. So the probability that X is equal to 0 is the same thing as n here is 5. 5 choose 0 times 0.2 to the 0.2 to the 0 times 0.8 to the 5. 0.8 just being 1 minus 0.2. Plus the probability that X is equal to 1 is 5 choose 1, 0.2 to the power 1, 0.8 to the power of 4, which is just 5 minus 1. Plus 5 choose 2, 0.2 to the power of 2, 0.8 to the power of 3. So you plug all that into your calculator. That will give you the answer for the probability that we get more than 2 correct guesses on this. All right?